Hello student, welcome back to Miss Mani's class, the chemistry class of grade 11. In this video, we will discuss about thermochemistry. Fireworks, it's really beautiful when it explodes. Do you know what fireworks make from? Yes, that's right. Mixed from chemical reactions of potassium nitrate, sulfur, and some charcoal. When chemical reaction take place, there is an energy change. Energy can take many forms, including heat, light, sound, and electrical energy. The chemical energy in the atoms and bond of a substance is also very important. One of the most obvious energy transfer in chemical reaction is the transfer of heat. A car engine gets hot when the energy is transferred from the burning fuel. Fireworks release a lot of energy as heat, as well as light and sound when they explode. Our body keeps warm because of the continuous oxidation of the food we eat.
Before we start to learn about exothermic and endothermic reaction, first we have to know about the term that we will always use in this chapter, in this session. System and surrounding. System is everything that become our object, and surrounding is everything around the system. From this picture, you can see that around the system there is air. If there is stable, and the Erlenmeyer, and also the cover of Erlenmeyer. There are three kinds of system. The first we call open system. Open system is the object will direct interact with surrounding. You know, there is no cover in this test tube. And second, we call it closed system. The closed system, the solution or the object, it cannot interact with surrounding, but the transfer of energy from the system to energy or from the surrounding to and the system still can happen. But the third, when we call it isolated system, the transfer energy almost is really hard to happen because the system covered by something that isolated the system. Now we continue to learn about exothermic and endothermic process. This is the reaction of methane and oxygen, or we call it combustion reaction of methane. Perfect combustion reaction of methane will produce CO2 and H2O. This is the molecule to interpret the reaction. Okay, now see this picture below. Methane has 4 bonds from C to H. Now, to break this bond, it needs energy. Also, for oxygen to break the O double bond with O, it needs energy. Break it bond will become atom. There will be atom OCH with its number. During the reaction, as with all others, bonds are first broken and then new bonds are made. This is, we break the bond, and this is, we form the bond. To break the bonds require energy. Energy must be taken in to pull the atom apart. Breaking chemical bonds take in energy from surrounding, and this is called endothermic process. And then the new bond formed from its atom. Ca2 made from C and 2O, H2O made from 2H1O. Forming this bond give out energy. Making chemical bonds give out energy to the surrounding. It will release energy to the surrounding. This is called exothermic process. The total energy of bond breaking are lower than the total energy bond of making. So overall of this reaction give out energy. The energy is release the heat to surroundings. So this reaction called exothermic reaction. So this is the graph diagram, enthalpy profile diagram. We can see from this graph that CH4 and 2O2 needs energy to react, to break the bond. And this is the line of energy needed, of energy taken. And then when it form to product, it will release energy. So it called exothermic process. Overall of this reaction will give out energy because the energy needed is lower than energy give out. So overall of the reaction is exothermic reaction. In this reaction, energy is given out because the bond of the product are stronger. The bond of the product are stronger than in the reactant. This means that the product more stable than reactant. So this is one of the reactions that take place when fuel is burned in the car engine. Nitrogen plus oxygen yields nitric oxide. The energy to break the bond of nitrogen and bond of oxygen is greater than energy to form an O. So overall of the reaction take in energy. The energy is absorbed the heat from surroundings. So this reaction called endothermic reaction. In this reaction, energy is taken in because the bonds in the product are weaker than in the reactant. This means that the reactant more stable than the product. This is the energy to break the bond of nitrogen and oxygens. And this is the energy to form nitrogen oxide. Energy to break the nitrogen and oxygen is bigger, is higher than energy to form nitrogen oxide. So this energy need or absorb heat from surrounding. Watch this picture and determine endothermic or exothermic process. Burning magnesium in air. It will release heat. So it's called exothermic reaction. Crystallization of copper 2 sulfate from saturated solution. This solution, this crystal of copper absorb heat from surrounding to make crystal of copper sulfate. So this is called endothermic reaction. This is evaporation of seawater. The water will vapor from the sea with the heat from the sun. So this is called endothermic reaction. Heat of reaction, or we can call it enthalpy change. The energy exchange between a chemical reaction and its surrounding at the constant pressure. Enthalpy is the total energy associated with the materials that react. The symbol of heat reaction is delta H. Delta means change in, H means heat or enthalpy. The unit of delta H is kilojoule. 1 kilojoule equal to 1000 joule. For the exothermic reaction, heat energy is given out or exit and delta H value is negative. For endothermic reaction, heat energy is taken in or enter and the value of delta H is positive. Measure the enthalpy change. We cannot measure enthalpy, but we can measure the enthalpy change when heat energy is exchanged with the surroundings. Delta H or enthalpy change is H product, enthalpy product minus enthalpy reactant. For exothermic reaction, H product is lower than H reactant, so the number of delta H of exothermic reaction is minus or negative. For the endothermic reaction, H product is bigger than H reactants, so the value of endothermic reaction delta H is plus or positive. Here's my reference list. Thank you.